Okay, 3, 2, 1.
All right, I think we're starting to get everything going live, so take just a minute to welcome everyone. We are waiting for our YouTube stream to get up and rolling. Producer Josh is in the house once again. We want to say a big thank you to him for running all the tech behind the scenes. Thank you, Producer Josh. Yay!
Sounds good.
Awesome. Well, it looks like we are all live and ready to go. My name is Jess Martin. I am the Communications Manager here at Harpeth Conservancy.
And I'm Ryan Jackwood. I'm the Science Director here at Harpeth Conservancy.
We want to welcome you all to Tennessee Water Watch Live. We're going to start out by talking a little bit about Harpeth Conservancy as an organization, and then we're going to dive right in, haha, pun intended, into a little bit about our water quality monitoring this season, talk a little bit about Tennessee Water Watch, what it is, what we found, and answer some of your questions. We hope you have lots of questions. If you are on Instagram, and you put your questions in the chat there, we might have to get to those in a little while. If you head over to YouTube, you can see the wonderful graphs that Ryan has made and that we'll be talking about, and producer Josh will be monitoring those questions live, so we will be getting to those as we are talking through this live session. But let's just go back to who we are at Harpeth Conservancy. Harpeth Conservancy is a conservation organization. We were founded in 1999. We started out as a smaller watershed association. It was Harpeth River Watershed Association, and we have grown a lot since then. And our mission is to restore and protect clean water and healthy ecosystems for rivers across Tennessee. And some of the ways that we do that is by employing scientific expertise and collaborative relationships to develop, promote, and support broad community stewardship and action. We use sound science, responsible policy, and strong community engagement to form the basis of our approach to advocacy. Ryan, you are the director over our science program. We have Marie, who's the director of our community engagement, and Elise, who is the director of Tennessee Water Policy. And between the three of you, you basically form this trifecta of, our work for clean water and healthy ecosystems that, kind of goes out into the world.
We complement each other in a lot of different areas. I might be working on something that gets passed to Marie or Elise, and then they take it further. So it really is kind of a nice balance of like those three different kind of sectors that we work in.
Yeah, and we really everybody on the team kind of just all works together. We thread it through many different areas. Josh is out in the field with our programs and our education. We have our wonderful development team who they're putting on events and inviting folks to come be part of our work, whether it's supporting us financially or getting involved in other ways. And then, I'm here with communications, making sure everybody hears about all of the things that are going on. So it's just, a team effort. And then behind the scenes, we have Katie, who's our operations manager. And she's, making sure she's herding all of us kind of like cats most of the time.
Most of the time it is like cats.
Yeah. So that's kind of who we are as a team. We have Grace and Dory, who are executive leadership. Grace is our CEO. Dory is our founder and president. She's been here for 26 years now. Longest running employee other than you, actually.
I guess I'm second place anymore.
Yeah. So, but we can't do all of this on our own, especially not the science. I mean,
Absolutely.
I know that you have, Eve, who's our lab coordinator, but the science team really relies on what we call community scientists. Can you tell us a little bit about what community science is?
Yeah, so one of our core programs here in kind of the science department at Harpeth is what's called Tennessee Water Watch, and it's a citizen scientist kind of program or community science program. And really, we need help. Rivers are huge. They're large. They're oftentimes a pretty decent drive away when you're trying to go visit them. And so if we want to have the kind of a robust sampling program where we can look at water quality, we can try to assess the health of these rivers, we need people to be able to get out to those places and to be able to help us get samples.
Yeah,
and so
absolutely.
we have an incredible list of community scientists. I think we had up to almost 30 this year.
Yes.
That were all kind of helping out in various ways. We had, I think, about 20 regular, weekly, reliable citizen or community scientists, and then we had another 10-ish or so backup that can fill in at a moment's notice. And obviously
Absolutely.
people go on vacation and people get have kids and back to school and all this stuff. So people have lives, and we value the time that they can give us. But it is incredibly helpful, and we couldn't do programs, all of the programs like we have that without their help.
Absolutely. It amplifies the efforts that we have here on our team. I know that, having gone out and collected water samples as well, that it does take time, and these folks are collecting samples almost 20 weeks for us.
Mm-hmm.
So, a weekly commitment across 20 weeks, that adds up. So we want to say a big, big thank you to our community scientists and water sample collectors. Thank you all for your efforts. This data and all of the things that we learn from these samples that they collect, it doesn't just stay with us. It goes beyond us, and we'll talk about more of that later. But their efforts it's impacting water quality statewide, really.
Yeah, no, I mean, we are certainly providing and helping those efforts to assess rivers statewide, and so that's a really important goal to have for this program as well.
Yeah. Well, speaking of water quality statewide, I wanted to talk about this next slide that we have. Over 8,500 stream miles in Tennessee are assessed by TDEC. Well, that are assessed by TDEC, are impaired for E. coli in Tennessee. And, as they put out this data, we see some of the common impairments of pollution and things. And I just wanted to talk a minute about the impairments and what that means and why bacteria is one of the largest numbers on this list.
Yeah, so this slide kind of breaks down the different water quality impairments kind of by, most common, really, in the rivers across the state. And so you can look, habitat alteration is about 38% of all of our assessed rivers. And so that's going to be the biggest one. That's a pretty broad general category. It can be anything from destroying a riverbank to, channelizing a stream. There's a lot of things that can go into that. So it's not necessarily one practice that's causing that. Now, of course, the next one is E. coli, and that's bacteria. And so bacteria comes from a lot of different sources, anything from, stormwater runoff. We often think that bacteria is kind of a fecal coliform. And so it's going to come from some sort of fecal source. It's not the most enjoyable thing to think about. But
we end up talking about poop a whole lot in this job. But, I mean, really, the source of E. coli is poop, really.
And so think about wildlife waste, think about dog poop that people are, leaving on their, sidewalks. Think about even sewer plants and overflows, and if they're doing maintenance and stuff, can get into the rivers that way. And then there's the whole world of agriculture. You've got livestock,
animals,
chickens, pigs, all of that stuff. Those types of manures can certainly contribute to bacteria pollution. And so that's why it's so common. We see it in rural settings. We see it in urban settings. We're going to look at that difference a little bit later. But
well, and with our current Water Wednesday education, one of the things we have been talking about is the water cycle, and we're talking about stormwater runoff, and that is a big factor in the runoff, the water washing over not just land, but impervious surfaces, those hard surfaces, especially in urban areas, that are going to pick up whatever it touches. And if you're in a park where there's a lot of dogs, or you're in a place where there's a lot of, well, even in farms where there's a lot of poo to touch, I mean, it's going to end up somewhere. So, continuing on, we see that, this next slide that we have, there's almost 400 miles of streams in the Harpeth River are considered impaired, and 125 miles of those streams are impaired for bacteria. And they are a mix of both agricultural and municipal sources. When we say agricultural and municipal sources, what are we talking about here? Obviously, agricultural, we could say farm, but, municipal sources would mean...
Yeah, I mean, you can kind of think of a little bit of, we probably immediately kind of think of utilities, so sewer plants, maybe it's even, you could even consider, like, some of these street runoffs and stuff like that might be more kind of municipal. Industry, maybe that there's a source there, depending on the type of industry they're in. Certainly, like food processing facilities and that kind of stuff. So it's kind of a wide variety of sources, really, but we can almost kind of divide them between, rural out in the country or kind of in the city,
Gotcha.
Which is which. And so that's usually, they both will have sources of E. coli, but oftentimes they're different.
Yeah. Now, when we talk about E. coli, we know from testing, E. coli is the easiest test for us to conduct.
Yeah.
And cheapest. So that's great for us to get a quick and easy picture. But E. coli is what we would refer to as an indicator species. It indicates the presence of other pathogens found in surface water.
Exactly.
And, it's not just maybe necessarily in the water. It could be in the sediment in the water or on other objects found in the water. But what does it typically point to? What are those other things that we should be concerned about that it might be pointing to?
Yeah, just because there's high levels of E. coli in water and you come in contact with it doesn't mean it's necessarily going to make you sick. E. coli is kind of this general bacteria species that is very common in the gut of warm-blooded animals. So
it's found in our
we have it
gut.
And it's kind of part of a natural kind of gut system. But it also indicates some of these other pathogenic species.
Right.
And so we know when E. coli gets higher, we're going to see stuff like Salmonella get higher. We're going to see stuff like Giardia get higher. And so it's very expensive to test for each of those individually. Theoretically, you could run a couple dozen of those tests and, it would cost a lot of money.
Yes.
But we can do E. coli tests pretty cheaply, and that kind of tells us the risk of, some of these other pathogens that could actually make us sick being present in the water.
Well, that makes a lot of sense. And some of those we definitely want to take care of because they have a really big risk of making you sick. Having had some sicknesses in the news and things recently,
yes.
I'm sure folks are a little bit more ears tuned to that kind of thing. But it's not something that we should be always alarm bell, because like you said, just getting in the water, you're not going to guarantee to be sick. When we're in the water, what are the things that we should be thinking about? Should we, just because we touch the water or...
Yeah, usually we kind of think about these waterborne illnesses, pathogens, think about kind of how it can infect you. And really we kind of immediately think nose, mouth, eyes, ears, that's
soft tissues.
Soft tissue. So if you're kind of ingesting it, if it's getting in your mouth, if it's getting in your eyes and your ears, that's going to obviously give a kind of a larger risk or a larger chance that you might get sick if something is present. Now, the other thing is cuts on your body. So if you've got some cuts, of course, bacteria can kind of infect or enter in that way. And so you want to be careful. And it's not just the face. It can be other parts. But really, we are mainly concerned with kind of face, soft tissue, those kind of things.
Probably people who are at more risk anyway should take more care. And, one of the things that I think that a lot of people probably don't think about is, their pets getting into the water, their fur gets wet, and then they get out and then lick on their fur.
Yep.
They are ingesting that water, but they didn't really think about that, as being a way to ingest it.
And, think of us as adults, we can say, well, I'm just kind of standing in the water, wading in and, maybe fishing or maybe just kind of splashing around. But kids aren't necessarily thinking about that. So they're all, they're going to be inherently kind of ingesting some of this water if they're splashing around. So we also need to kind of remember that it's, just because you can, to protect yourself, make sure people you're with too.
Well, I had someone tell me a story that they had gone paddling and they weren't in the water, they didn't touch the water, but afterwards they had developed a case of pink eye or some kind of infection, and they realized that they had been doing this, wiping the sweat off of their face the entire time, and they had touched the water with their hands or
The
when they were
paddle,
paddling,
yeah.
and so the water had potentially gotten into their eyes that way. So there are ways that water can enter the system that we don't necessarily think about. So it's
Sure.
always great to have a clean water source to wash your hands or sanitizer or something of that
exactly.
nature. All right, well, you know, let's get into the 2026 sampling season. We collected a ton of samples this year.
And we're not done yet either.
We're not done yet. That's the great part. I have to just say out loud and be a little bit, because I had the sole distinction of being the only person to collect a sample from Centerville this year, and I was really excited about that, to go down and collect from the Duck River.
Yeah, unfortunately, we couldn't find a volunteer willing to make that drive this year.
Yes.
And so if
we
you're,
are
if you're
looking
interested,
for samplers from the Duck River area. If you are interested, let us know for next year, because we would love to get more samples along the Duck River.
Yeah, but hopefully you can see this map that we can kind of pull up here. But we've collected almost 250 samples so far, which is probably going to eclipse our most ever. But by the time we're done with the season,
I would say so.
We had 20 different locations, and this year we had our highest E. coli value that we've ever seen at any location.
That's a big wow. So, so we test out of 100 milliliters. We had a sample that tested 21,776.4. Wow.
It's massive. The EPA, for context, recommends 235 as the threshold to say if it's above that, you should be careful. If it's below that, you're probably fine.
Yeah, so that's the threshold for safe recreation, below 235. So this, just to do some quick math, I'm not very quick at math, but let's see, 21776. That's almost 10 times. I mean, it's about 8 points.
No, it's like 100 times higher than what the EPA
yeah, 100
standard
times.
would
Sorry.
be. Yeah.
Again, not great at math.
But no, it was incredible. We had seen levels in previous years at 9,000 or so. So this was over double what our previous high was. So it was pretty incredible. We might talk about it a little bit later, but it was at our West Harpeth location.
Just trying to do math still.
Yeah. Did you come up with it?
No. Maybe producer Josh will break out a calculator on the side, because my brain just went zing. All right. I will pay back attention now.
There you go. All right. So let's kind of jump to this next map and look at some results from kind of our different locations.
All right.
And these are just really kind of averages. It might not be the greatest way to look at E. coli data because it is so volatile that we'll see, but really just kind of give you an idea of the area, the regions where we're seeing higher E. coli levels versus lower.
Oof.
And I first kind of want to draw you to, some of these small urban streams. Think of Browns Creek, think of Richland Creek, think of Mill Creek. That's going to be where we're seeing kind of some of our highest numbers. I mean, it makes kind of sense. It's a lot of human activity.
Yeah.
There's a lot of development around these areas. They typically have smaller of a floodplain because they've been built up over years, so fewer protections from a water quality standpoint. So we kind of expect that with some of these really dense kind of urban kind of streams and areas.
Yeah, thinking back to our reports from this year, I think the highest regular samples that I saw were around Browns Creek, Richland Creek, Mill Creek.
Mm-hmm.
Yeah.
And then kind of what might surprise some people is if you look at, we've got actually 4 locations, well, technically 3 locations along the Cumberland River, and all 3 of them are some of our greenest sites, so some of our lowest E. coli value sites.
We added 2 new sites on the Cumberland this year, 2 in Ashland City, and they were amazingly, they both
very, very low E. coli values
all year long.
All of them. It's pretty common for one of our Cumberland sites to be the lowest value every week. So that's been fascinating to kind of learn and understand. Now that doesn't mean the Cumberland River is this perfectly pristine, clear from a water quality perspective, but at least looking at E. coli specifically, it's it probably dilutes some of these sources so much that we're really not seeing much in it.
Yeah, one of the questions I get routinely is, how dirty is the Cumberland?
Mhm.
People have this, idea that the Cumberland is super dirty. It's full of E. coli. It's, and it may have water quality problems. There may
Absolutely.
be impairments in it. There may be problems with it. But E. coli, from what we've seen, doesn't seem to be one of them.
Yeah, that doesn't seem to be much of a problem for the Cumberland at all. And then if you kind of look at, some of our, say, like rural streams, but really kind of the Harpeth, the
Yeah.
Duck, the Stones, we get a little bit of a mixed bag. Obviously, the Harpeth flows through Franklin, so there might be some influence there. Even the Little Harpeth and the West Harpeth were actually, were kind of high over the past couple years. And so we're keeping our eye on those as well. But,
Yeah.
that's the kind of difference between some of these, urban versus rural kind of areas.
Now, the Little Harpeth, it is a really great spot where we test, but it is around both a dog park and inside a park where a lot of dogs play. Do you think that
Yeah.
that could be a factor?
I think it certainly could be. It's really, really hard to tell. It could, obviously
yeah.
the Little Harpeth flows through Percy Warner. That's going to have a bunch of wildlife as well. So, is it dogs? Is it wildlife? Is it, the, communities upstream, of
Yeah.
where the kind of the Little
I mean,
Harpeth
there's
flows?
a golf
So,
course
golf
nearby.
course, yes.
Lots of fertilizers, lots of potential for other problems and
Absolutely.
things. Yeah, it's really hard to make conclusive statements when, you don't really know exactly where it's coming from, but, knowing the land around a site is really important.
Absolutely. I mean, I've certainly walked areas on the Little Harpeth, and I've seen, piles of dog poop that were not picked up. And so
Absolutely,
that's going to
same.
eventually get into the river right there, and that could be some of what we're seeing in our samples.
Yeah,
But
definitely. Well, one of the questions that I get asked all the time, and it's really tricky to answer, and I want to see how you answer this,
Okay.
is the water quality getting better or worse?
Yeah, I know. This is a tough question.
Yeah.
And so I tried to put together kind of some information, a couple graphs to add some context, some nuance to to this question. So first we can kind of look at, first let's talk a little bit about in context. So we have been developing rivers, we have been developing around rivers, we have been human activity around these things for many, many, many years.
Yes.
It is probably only really recently that we've kind of started to understand the impact that we're having on our rivers from a health and water quality perspective. And so when people kind of say, well, is it getting better? Maybe marginally, but it might take us another 50 years for some of these rivers to really kind of improve them because we've been screwing them up for 50 years. It's hard
That's
to,
fair.
it's hard to kind of reverse everything in a super short period of time. So I'll add that a little context. And then if we kind of look at this graph of White's Creek, you can see that even though we are out there sampling on a weekly basis and we're trying to do it every year, and we've done it for almost 6 years now, we still don't have so much data that that question is easy to answer. You can kind of see the gray dots in each year, and there's a huge range between them.
Yeah.
And so we can kind of maybe start, seeing some trends or say, start speculating that maybe it's getting better. But this White's Creek graph, that N equals 6 right above the 2022 year, that means we're six samples collected that year. And so we're kind of saying, based on those 6 samples, maybe the river's getting a little bit better, but 6 samples is very, very few samples from
Yes.
a water quality and river standpoint. So it's tough to rely on that alone. And then, we only have 19, 17, 11, and, subsequent years. So did we get maybe a little bit more rain that year? Was there just something that random kind of happened? Or is the river really kind of trending in a better direction? We can then look at the Cumberland River, same kind of thing, but the Cumberland is so massive, I don't think anything we're doing locally is having any impact. So
Yeah.
maybe we have to go look, way upstream or something like that. And again, it's a fairly minor improvement, but this is the kind of makes it statistically significant, So we kind of are seeing that with the Cumberland, and then we can kind of go to our last one here, the Little Harpeth. And we're seeing the reverse trend on the Little Harpeth, that maybe between 2024 and 2026, it got a little worse. But that doesn't mean in 2027 it might get a little better, and now all of a sudden we're kind of bouncing back and forth and probably staying fairly consistent or kind of
Yeah.
having this even keel. So that's really, we're excited to keep going into the, years into the future, and maybe once we have 10 years of data or 15 years or 20 years, we can really answer that question more accurately. But that's kind of why I wanted to, put these graphs up there and kind of talk through them. And just so you know, these were the only 3 locations that had any kind of significant trend. So we had 2 that looked like they were getting a little better, 1 that looked like they were getting a little worse, and then all the other ones kind of were just like no statistical significance from year to year.
That's interesting. Now, I would imagine that, as you look at year to year, when you're sampling, if the sample falls on a day when there's a lot of rain, then, that could have a huge impact. And if the samples fall when there's not a lot of rain, that, the days that you sample on, the flow of the river, other factors all feed into this, that what all goes into looking at this that makes the factors, the graphs look the way they do.
Yeah, so you're right. And, if you think about it, let's say you sampled 5 times in 2025 and all 5 of them were right after a rain event, and then the next year you sampled 5 more times and they were all when it was really dry. Well, the rain events probably cause your E. coli values to go way up. And so trying to compare one year to the next is going to be totally skewed, because it's going to, you're going to be reflecting wet weather versus dry. Now, what these graphs are showing is trying to adjust for that. And so we're trying to kind of remove the influence of rain and just kind of say, well, if there was no rain, what would the E. coli have been like on that day? And then try to compare year to year. And so that's kind of what we're doing here. But again, with so few samples, that modeled correction, that kind of removing that flow influence, is not going to be as good with few samples. And so that's why we want to keep collecting more and more samples, so we can kind of really hone in on what that flow influence is, and kind of then get to that way we're comparing apples to apples really.
How many samples do you think it would take in a year to get that amount of data?
That's tough, because you almost, I'll do a cop-out answer where it's like more data is always going to be better. There are actually statistical tests. There's a test called a power test that you can actually do to hone in on. It will tell you how many samples you need to collect in order to try to kind
of like a break even.
Yeah, try to suss out that relationship. So we can kind of figure that out. It's probably in the hundreds to 1,000 or something, but
if you want to be 100 sampler,
if you want to do some statistics and try to figure that out, we certainly could. But
well, those look great. I mean, it's encouraging to see just that we have this continued data collection year after year, and even if we aren't collecting hundreds of samples, the fact that we're continuing to build the program, we're continuing to collect more samples year after year after year and build on this, I think for me it's encouraging, and I hope that folks realize the importance of this work, the importance of the data collection, even if we're not getting those hundreds of samples.
We're making progress.
We'll get there
eventually, but it takes time. It always takes time with these things, and that's
absolutely.
And that is why they kind of call it. I mean, this is truly like we were intending this to be kind of like a long-term, data study.
Yes,
and so,
absolutely.
We're trying to be in it for the long haul.
Yeah. Well, we're looking at Earl. Not Earl. Urban versus rural, another word I can't always say, streams. And, there's a little bit of a difference in distribution by stream setting. And that's another interesting perspective here. Tell us about this.
So what this is kind of showing us, the kind of orangish yellow line in each of those blue boxes, that's the median. And so we can kind of show that, all right, our urban streams on average are kind of for the median is going to be higher than our urban or kind of, urban streams are always going to be going to be a little bit higher probably than our rural ones. And so think city versus kind of the countryside, which is, we may expect kind of that. But then if we look over at kind of the rural distribution, sometimes it can be very, very, very low, much lower than our urban ones. Think like it has a much lower floor, but it also might have a higher ceiling.
Yes.
You can see that we've got some of these dots that are kind of way, way up high in some of our rural areas.
It's a much more drawn out plot line.
Yeah, so I think that, we might, on certain specific days see, E. coli much higher in these rural streams and areas than we would see in urban one. But, the urban ones are probably more consistently going to be higher than the rural.
Do you think that has anything to do with a smaller floodplain that they have? And on some of those days where the rural areas have a wider floodplain, maybe some of the the water reaches places that have higher concentrations of animal waste, and that's getting washed in on heavier rain days or anything?
I think that there could be a variety of reasons for this. It certainly could be watershed size. I mean, based on kind of our sampling points, the urban kind of city streams are much smaller watersheds, and so maybe that there's fewer kind of number of like E. coli sources within them than a huge big watershed like the Harpeth or something like that. There also could be whether it could. Rural ones are probably more rain-driven than urban ones. Urban sources might be more kind of consistent. They think we're not necessarily flushing our toilets more often when it rains than when it doesn't rain. But in a rural kind of agricultural setting, if you've got if you just spread manure on a huge field, that might be a massive source of E. coli, and that's maybe why we're seeing some of these really, really high values during those rain events. And to be fair, we only see maybe 2, 3, or 4 kind of samples that are showing
kind
it.
of those outliers,
and that might be our one on the West Harpeth that we collected this year that was our highest ever. And so so we're seeing, even though that we can kind of see a relationship here, it's also driven by maybe only a handful of samples in some cases when we're trying to do this analysis.
Yeah. Well, we have one last graph to look at, and it's kind of looking at that influence of weather, and we see in that purple section that heavy rain. It looks like some of those high outliers there.
Yeah, exactly. So I think this is such a fascinating graph, and I think that it really kind of shows what we try to explain to people all the time. Kind of all the way on the left are, box and whisker. Again, that kind of middle black line in the box is like our median. So it's like, you can kind of think of it as an average, but it's a little bit different. And then our, distribution, our high to our low. Well, during drought, very little rain, obviously that is going to be when we see our lowest E. coli values.
Absolutely.
That is going to be, normally that's kind of when we think of, we're not getting runoff, we're not getting like additional sources of E. coli. It's just kind of what's in the river at that time.
Yep.
Then we get, heavy rains. Well, actually, let's go all the way to the right. Let's go to light rain. So that's light rain that is like maybe rained a little bit, half an inch on a Monday, rained a quarter of an inch on a Tuesday.
Or isolated.
Yeah, so and it's kind of happening like, fairly regularly, maybe with a couple days of dry weather in between. And that's going to increase our E. coli amount. We're getting the runoff, we're getting, sources from the dog parks, like you mentioned, and that kind of thing. And then we've got this idea of a first flush.
Now, what exactly is that?
So first flush, we would kind of call it, it's been dry for a week or two. And so you've accumulated a lot of this like debris on the roadways, or you've, now the neighbor has, walked their dog 10 or 15 times in between rain events.
And the ground might not soak up
and
things
the ground's not
away.
soaking up. Now the wildlife has run around and they've had several more days or weeks to, add to the waste to the area. And so first flush is then that first rain event after that. It's a small rain event. It's not massive, but it's right after that. And we always expect we're going to see higher E. coli levels then because more of this deposition is kind of waiting to be flushed into the river. And so we see that reflected in the data that, a light rain compared to a first flush event is, we're seeing more in the first flush. Yeah. And then finally, the end all be all is these heavy storm events, these massive downpours that no matter, how embedded this waste is into the soil, no matter when
rivers turn to chocolate milk.
They turn to chocolate milk. You're probably removing like sediment off of some of these sources. You're causing erosion. So that's when we're obviously going to see our most consistent time of the highest levels of E. coli. And so after huge heavy rain events, probably avoid some of our rivers. They're probably
Definitely,
flooding
yeah.
anyway, maybe. So,
Well, when those
certainly
water
avoid them.
levels are high, you pretty much can
Mhm.
kind of assume that the E. coli is
Exactly.
a little bit high as well.
But even if it's been really, really dry for a while, and then we get a little half an inch of rain, and maybe the river doesn't seem like it rose that much, or it's but that might also
Yeah.
be seeing some decently high E. coli values, and so just kind of gives you a kind of a little bit of a rule of thumb, or a little bit of an idea of how these weather conditions kind of impact the samples and the data we're seeing.
I think it's really interesting, and in our Tennessee Water Watch reports that we do post, I always try to give a little bit of an insight into the weather and how we relate it to what's the data showing. This past week we didn't have a whole lot of rain, so it was mostly green.
Our numbers were really low this week, yeah.
This week, the Water Watch report's getting ready to come out. You're going to see it's mostly green again.
Mm-hmm.
We haven't had much rain. We did have a little bit of a light rain, I think yesterday or day before.
Yeah.
And we'd already collected our samples for the week and processed most of them, I think. But even a light rain like that, the thing about the E. coli testing is we're always looking backwards. Even if we test on Tuesday and we process them and we are getting our results on Wednesday, those results, by the time we finish processing the test, well, they could change.
Exactly.
So that's why Tennessee Water Watch is so important, isn't it?
Yeah, I know. And so that's why we have our models and we have our forecasts on our website and our dashboard. And that's why, we think that that's so important, is because, like you said, if it rains today or tomorrow, then, it might not be reflected in kind of the samples that we collected earlier this week.
So, I mean, that isn't to say that our tests aren't correct or anything like that. It's just to say that if you want the most up-to-date forecast, check Tennessee Water Watch. Yes. We always say before you splash and play, check Water Watch for the day. Get your forecast for the day.
Yeah.
Before we talk about what's next for Tennessee Water Watch, let's go to producer Josh. Do we have any questions from anyone watching?
Not right now, but if anyone wants to ask a question.
If anyone has a question or would like to, pop in on the chat, we would love to hear your thoughts or answer your questions. We are excited to talk about water quality, talk about whatever you want to talk about.
Exactly.
It doesn't have to be about water quality. We could talk about other things too. So we'll hang out here for just a second and see if anyone drops a question. But yeah, I mean, Tennessee Water Watch, this has been a great program so far. We've, this year, what are some other things that we've looked at this year? We've looked at algae this year. That's been a lot of fun. It's not necessarily E. coli related or water quality related, but we did investigate some algae.
Yeah, we've collected some samples and thrown some slides under the microscope and kind of look. And I know that Eve, our science coordinator, even just emailed me the other day and was showing me pictures of diatoms that she was seeing under the microscope, which was pretty neat.
I did the project with the interns looking at different types of algae that we found in various creeks, streams, and lakes around Middle Tennessee, and we identified a bunch of them and talked about not is it harmful or is it helpful, but what were the words that we decided to how we
did you call nuisance and nuisance algae versus probably like you can say like quote natural algae, I
something
guess,
like that. I can't remember how exactly we labeled them, but we didn't want to hurt any algae's feelings.
I've got a question for you.
Yeah, let's hear the question.
This is from CC Wilkes on YouTube. It says, "Hey HC, relatively new testing site at Browns Creek Hart Bridge. What are we looking to learn or accomplish from testing there?"
Hey, yeah, great to hear from you. We had a Browns Creek site right there in Battlemont Park for a number of years, and that is always kind of consistently one of our highest locations.
Yes.
So I was kind of expecting to see some high levels of E. coli at the Hearts Bridge site, and we
And
did.
we did,
Yeah,
yeah.
it was certainly higher this year. I'm trying to kind of see if there's any difference between the two sites eventually. Now, I think we definitely need more samples at the Hearts Bridge site. But we're also thinking, if there is going to be any kind of work in Browns Creek, or
Yeah,
if there's,
absolutely.
we'd love to see some restoration work and some, improvements to the area down there. We want to establish a baseline of E. coli before that stuff kind of happens. And so we're really excited about being able to maybe show a water quality improvement before and after if kind of any of this kind of cool work gets done.
Yeah, I think one of the great things about having that baseline of data, especially with knowing where we've started, and then being able to do on the ground restoration projects, and whether it's cleanups, or invasive species removals, or even something more in depth like a stream bank restoration. There is some erosion along that area there, and then seeing the level of E. coli drop is to be able to take that to the community and get further investment from the folks who are living along that area. Being able to say, this is the difference that you've made.
And I will also say we're also testing for turbidity there. We actually test for turbidity at all of our sites, and it's basically the cloudiness of the water, but it gives us a good idea on sediment and kind of
Yes.
erosion that's happening. And so that's also what we want to see in Browns Creek, is if we can,
Absolutely.
that's a great way to kind of monitor water quality, is this kind of turbidity measurement.
Yeah, and another thing, where we have 2 testing sites on Browns Creek, and we are consistently seeing these high numbers, one of the things that, Ryan and our science team can start doing is say, okay, well, we know that these are high levels. Where exactly is it coming from? And is it further upstream? Is it further downstream than these sites? And then start working to actually pinpoint the source of the pollution and work towards policy solutions with our policy team.
Exactly. Yeah, no, that's great. Well put.
Excited about answering more questions. Does any folks have any more questions?
Maybe we could say what's next and then
All
answer
right,
questions.
let's go to what's next. Producer Josh had a great idea. What is next?
Well, we're always every year we're trying to expand the number of our sampling sites. Now, we want to be strategic about it the best we
Yes.
can. It's not just like, take any site that we can possibly think of. It's really,
Yes.
we want to make sure that publicly accessible. We want to pick areas
No
that
trespassing.
yeah, we want to pick areas that people use and that
Yes.
actually, value that information. We want to pick areas where it's safe to get in and collect a sample, and then obviously strategically, if we've got 2 sites that are too close together, that doesn't necessarily help us as much as
No.
going to a completely different watershed. And we were getting to the point where we're kind of having to drive farther and farther away to add new
Yeah.
sites. So that's also making it a little bit more of a logistical challenge.
So definitely, with the safety in mind, with, expanding our sites to kind of be mission minded, especially where we are a small team. I know that, there's times where we don't always have, it's kind of all hands on trying to get these things done. We want to definitely be thinking about, who we can partner with. So, if there's people who are interested in volunteering, or even other organizations that are interested in partnering with us, what is one thing that they can do? They can email you?
Yeah, you can email me or email kind of our info email on our Harpeth page, and that'll certainly eventually get to me. You can always call our office number too.
Absolutely.
But yeah, so usually how this works is we assign one volunteer to one location, and that's kind of their location for the year. But I'd be totally fine if an organization or a school group or a church group or something like that wanted to take over a location, or even suggest a new one that we aren't doing yet, and kind of help be the volunteer
Sponsor the site.
sampler coordinator, sponsor, however we want to do it. But I think that there's some real cool opportunity there to help us as a community scientist, but also help steer where they would want water quality information, in their local streams and rivers.
We're gonna pop over to a question.
Yeah, speaking of partners in the community, We've got a question from K2 the Schmidt that says, with the Cumberland River Compact's DPAVE projects, have you noticed any differences?
I actually wouldn't know necessarily if our sites have a before and after for any of their deep pave projects. Now, I think that's a little bit of our hope for the Browns Creek. I don't think any of that work has been done yet. But I should get on and check CRC and see if any of their deep pave projects are upstream of any of our sampling sites.
That would be a great.
I would expect that, there could be some improvements depending on the size of the project, depending on kind of what was drained there before. It's obviously, having grass and, more natural and soil is going to be
Native
better.
Plants
Better,
are always good.
better than a parking lot per se. But, so the work that they're doing is so great.
It's
and
amazing,
if we can help show the water quality improvements with our data, we are absolutely going to.
Yes, and we are excited about all of that they are doing there.
Mm-hmm.
All right. Another thing that we are hoping to do, I know that we are hoping to continue improving our predictive model with Tennessee Water Watch, improving, how it functions, improving the features that we have. Do you want to talk a little bit about that?
Yeah, so after every sampling season, so sometime in the fall, I gather all the data that we collect from that year, and I rerun our models, our predictive models. And so these are the things that are, if you're on our Tennessee Water Watch dashboard, these are the models that are showing you whether it's red, orange, yellow for that day.
For those of you who haven't looked at the dashboard yet, go to TNWW. waterwatch.org.
There you go.
It is amazing. You will love it. Try it out. Just plugging it.
So the more data we get for each of our sites, the more accurate we're going to be able to make these models. And so we have a different model for every single location. And I think we have 14 different locations right now that we're making predictions for. So we have 14 different mathematical models that are behind the scenes in that dashboard. And so every year I want to update them. I want to add the new data that comes in, see if there's a better model that we can develop by adding that new data in. And then I have aspirations of trying to bring in machine learning or an AI aspect to make the models even more accurate.
Yes.
Now that's,
We've talked about a lot of those things.
It may have to take someone with a little bit of outside expertise to help walk me through how that would work, but I've been doing some research and I've been trying to figure some of these things out.
Amazing.
So I am excited about the opportunities to kind of bring in or create more and more accurate models with maybe some different techniques than what we're currently using.
One thing you have to understand about Ryan and I, we both love coding and we kind of nerd out sometimes on this stuff, but we've had like these cool chats about the possibilities of things, and we're both really excited about where this can go, but sometimes we have to slow ourselves down
a little bit. Yep.
But there's so many cool features that Tennessee Water Watch could have, and if there are features that you all can think of that you're like, I would love to know this or think of this, we would be excited to hear from you all. What would you like to see as a feature? Not to say we can promise that, but just as feedback. What would you like to see? What would you like to learn that you think would be easy and useful for everyone? What are some things that you might like to see eventually happen on there?
Yeah, well, this year we had a couple new features. Actually added a hydrograph for every location, so you can see the current water flow at any of our sites.
That was probably my favorite thing you added this year.
Yeah, and it even has a little descriptor, so you can almost even use it a little bit of like, is the water low enough or too high for me to kayak, or is it just right?
That was probably why I liked it this year, because I was able to answer folks' questions very easily.
Yeah, so that's been really exciting. We also have we actually have available now all of our historical data, so you can go and you can look up and you can click, let's say, the Cumberland River and see all of the previous E. coli samples that we've taken, and you can even download it as an Excel spreadsheet, and so you can kind of use the data yourself. And I'm really hoping to kind of keep expanding these kind of features. I want to give a little bit of a shout out to Eric, who runs the Can I Kayak website. I just talked to him the other day, and it's canikayak.com or .org, I can't remember, but he kind of has like a current, this is the water level in the Harpeth, and tells you whether or not in plain English, whether he would recommend it's good enough to go kayaking or not.
That's really cool.
I would love, so I'm hoping to maybe incorporate a little bit of his his guidance into that.
Maybe we can even put that little widget somewhere on our
I know.
website.
I think that would be great. Maybe in the future it's a phone application or like an Android store
I
or
have been
Apple
on
store.
the app train since I started. You don't have to convince me.
And and I would love to hear if people have other feature ideas for the dashboard, because we want to make it as user friendly and as usable for the community. And I might have different opinions on what I would think is useful, and so I shouldn't be making all those decisions myself.
Well, sometimes I help get you
That's
in the right
true.
direction. All right, Josh, what do you got?
Yeah, we've got Kincaid TK that says, if you need help testing on Richland Creek, I can do that on a regular basis.
Amazing.
So we've got
Perfect, yeah.
TN Water Watch volunteers.
Yeah, reach out.
Send us a message. Send us a DM with your email, and I will make sure you get connected to the right folks.
Perfect.
Thank you.
Already recruiting for next year. I love it. Yeah. Actually, and that brings up a good point. We typically, you can reach out to me any time of the year. And then in about the March-April period, I send out a kind of a recruitment email to all people that have expressed interest in community science.
I always do a post and try
Jess
to promote
usually
it
does
too.
a post. And so I will send out a survey that people will take, and it kind of gives you an option which locations would you be interested in.
Mm-hmm.
You send that, or you fill that out, and then you kind of go on my list. I'll say
You're on the list.
on the list, and so then I reach
Sounds
out.
so ominous.
I know. And I'll reach out via email and get people assigned to certain locations, and make sure
Sweet.
that they are. They're still willing to do it for the year and stuff like that. So
Love
I'm
it.
happy to take emails anytime during the year, but we start kind of assigning folks in April. So reach out before then at the very least.
We'll start collecting names as of now.
For the list.
All right. Well, we are going to go ahead and wrap this up. We went a little longer than we thought we would, but we love talking to y'all.
Oh, it's been great.
So thank you for tuning in. We will come back next time, talk about another topic. Let us know what you want us to talk about.
Happy to do it.
Happy Friday. Thank
Thank you all.